This video is lesson 11 of the Hands-on Equations learning system. And in this video, we're going to learn that some algebraic equations cannot be solved by simply removing pawns. So we're going to look at a strategy for solving those types of equations. So for example, in the equation at the top of the screen, 2x equals star plus 6. When we set that up, we have two x's on the left-hand side and a star and a 6 on the right-hand side. However, when we look for legal moves that can be used to solve this equation, we don't see any of the game pieces that can be removed. Remember that our number one rule with equations is that we must keep them balanced at all times. In order to figure out the value of x over here, we'd like to get this number 6 by itself, meaning we'd like to remove this star. However, there's no star on this side for us to remove it, and there's no blue pawn over here to make a zero pair. Now, be careful. You might be inclined to say that there is a zero pair on here because we do have an x and a star both in the equation. But remember, a zero pair has to be in the same pan of the balance, meaning that it has to be on the same side of the equation. And we don't see a zero pair anywhere on this side or on this side. The x and the star are on opposite sides of the equation, so they do not form a zero pair. So as a result, we have to think about a different approach to get this 6 by itself and to somehow get rid of this star. And this is where you kind of will need to think backwards. We know that if we remove a pawn of the same color from either side of the pan balance at the exact same time, the pans do not move down or up. The system stays in balance. Well, the opposite is also true. If we were to add a blue pawn to each side of our equation, we would not change the balance of that equation. And if you think about that, that's because we put the exact same weight or the exact same value on each side at the same time. So now that we've added a blue pawn to each side of the equation, we can see that we now do have a zero pair on the same side. This blue and white pawn together, because they are opposites, has a value of nothing, 0. So I can now remove them. And now I have 3 x's equals 6, so 3 times what is 6? 3 times 2 is 6, so x equals 2. If x equals 2, star then would have a value of -2. Now this is where it becomes very important to reset your equation to its original state and then perform your check. It's very easy to make a mistake here, especially when you're removing and adding different colors of pawns at the same time. So x had a value of 2, star had a value of -2. On the left-hand side, we have 2 plus 2 is 4. On the right-hand side, we have a 6, and then we're subtracting 2 from it, which is also 4. So our equation is balanced, 4 equals 4, for an x value of 2 and a star value of -2. Here's another example of an equation where at first glance it appears that there are no legal moves to solve it because we have 3 x's on the left and a star and a 4 on the right, and there's nothing that we can remove from both sides right away. However, if we want to get this 4 by itself, we can add a blue pawn, an x, to each side, because what we just did was put the exact same value, the exact same weight on both sides. Now we have a zero pair that's on the same side, so I can remove this zero pair. And we have 4x equals 4. 4 times what equals 4? 4 times 1 equals 4. If x is 1, star would have to be -1. Reset your equation to its original state, and then substitute the values of x and star. X has a value of 1, star has a value of -1. The left-hand side is 3 1s. The right-hand side would be 4 minus 1, which is also 3. So our equation is balanced when x equals 1 and star equals -1. I encourage you to try this one on your own. Pause the video, either work it out using manipulatives or drawing pictures, and then unpause the video to check your solution. In this problem, we have 3 x's in the left balance And in the right balance, remember that this means 2 stars, not 2 plus star. So we have 2 stars and then 15. And I want to try to get the 15 by itself in one balance. So it looks like I want to try to get rid of these 2 stars over here. To get rid of those 2 stars, I can add a pair of x's and then another pair of x's. And what that just did is it gave me a 0 pair right here and a 0 pair right here. So now I can remove one 0 pair and then a second 0 pair. And now I have 5 x's equals 15. So 5 times what is 15? 5 times 3 is 15. If x is 3, star must be -3. Reset your equation to its original state. 3 x's on the left, 2 stars on the right, and a 15 on the right. Substitute the values for x and star. X had a value of 3. Star had a value of -3. On the left, we have 3 plus 3 plus 3, which is 9. And on the right, we have 15 minus 3 and then minus another 3. So 15 minus 3 is 12. 12 minus 3 is equal to 9. So we've completed our check. Our solution is x equals 3, star equals -3. So in this lesson, we learned that when we set up an equation and there's not immediately a way for us to remove either pawns or number cubes, we have to use a different approach to get pawns on one side and numbers on the other side of our equation. The strategy that we used was to add a pawn of the same color to each side of the equation. And just like we are allowed to take a pawn of the same color away from opposite sides of the equation, we can also add pawns of the same color to opposite sides of the equation without affecting the balance of that equation.